A very good afternoon to one and all. It gives me immense pleasure to extend you a very warm welcome on behalf of the Department of Statistics, St. Thomas College, Kottayam.
In today's world of digitization, data plays a very important role. The growing importance of decisions and opinions based on data can be achieved with the help of the subject statistics. In this context, the department is organizing a webinar on career opportunities and applications of statistics, which will surely be helpful to the students who want to pursue their career in the field of statistics.
Let us begin the webinar with a prayer song.
നന്മയാകുന്ന കാന്തി കാണുവാൻ കണ്ണിനാകേണമേ നല്ല വാക്കിൻ്റെ ശീലു ചൊല്ലുവാൻ നാവിനാകേണമേ സ്നേഹമാകുന്ന ഗീതമോ എൻ്റെ കാതിനിണയാകണേ സത്യമെന്നുള്ള ശീലമോടെ ഞാൻ ശാന്തിയറിയണമേ. May I now request Professor Lichi George, Head of the Department of Statistics, to deliver the welcome address.
Respected Principal, Dr. Matthew P. John, Chief Guest, Dr. K.K. Jose, Dr. Biju Thomas, HOD, Department of Statistics, Sree Sankara College, Kalady, Dr. Steffi Thomas, HOD, Department of Statistics, BCM College, Kottayam, faculty and students. A very good afternoon to one and all. It gives me immense pleasure to welcome you all on behalf of the department and St. Thomas College, Kottayam. This is the first endeavor of the department after being raised to the status of a PG department with the introduction of MSc Statistics. The webinar has been organized in collaboration with Sree Sankara College, Kalady and BCM College, Kottayam. Statistics is an art of persuading the universe to yield information about itself, and the statistician gives reliable truths and possibilities based on the information obtained, which helps the decision makers to take right policy decisions which may have far-reaching implications. We all know that COVID-19 pandemic has brought an uncertainty about the future in all walks of life. Almost all countries in the world have struggled to navigate through the pandemic, but statisticians mobilized to provide data and analysis on the gravity of the pandemic in each country and in each state. Their work has shaped life-saving policy decisions, which is an essentiality in this fight on pandemic. In the process of vaccination also, the role of statistician remains crucial. In fact, a career in statistics is one among the fastest growing and top paying jobs in the world. According to US Bureau of Labor Statistics, job growth in the statistical field is forecasted to be 35% higher in 2029 than in 2019. No matter what the future holds, by pursuing statistics, you are setting yourself up for a bright future. Statistical skills are in high demand in virtually every sector. With these few words, let me come to my responsibility of welcoming the audience. We, the Statistics Department, has got every support and guidance from our principal, Dr. Matthew P. John. He has been instrumental in getting this new course, MSc Statistics, at our college. He is a person with a very positive approach and extends all possible help and support in all our endeavors. Sir, I wholeheartedly welcome you, sir. Next, I welcome our chief guest and speaker of the day, Dr. K.K. Jose, Honorable Director of School of Mathematics and Statistics. He is the retired principal of St. Thomas College, Kalady. He has nearly 220 research publications, both national and international, and 14 books to his credit. He has produced nearly 15 PhDs in statistics and a few are ongoing. He is holding referee, editor and reviewer positions in various national and international journals. He has been honored with Indira Gandhi Sadbhavana Award, Rajiv Gandhi Shiromani Award, Sir Isaac Newton Award for Excellence, Global Achievers Award, and many other teacher awards, Best Principal Award, etc. Sir, we are really proud and privileged to have you as the speaker of this webinar. Sir, I welcome you wholeheartedly on behalf of the college and the department. This webinar is organized in collaboration with the Statistics Department of Sree College, Kalady BCM College, Kottayam. The department heads very willingly collaborated with this attempt. I wholeheartedly welcome the HODs and faculty members of all the colleges who are participating. Lastly, I welcome all the students who are participating in this webinar. Welcome one and all. Thank you.
Thank you very much, ma'am. Your thought-provoking address set a perfect platform for our speaker to deliver the presentation.
Next, I would like to invite our principal, Dr. Matthew P. John, to deliver the presidential address.
St. Thomas College Statistics Department Medhavi P.G. George teacher. ഇന്നത്തെ വെബിനാറിൽ മുഖ്യ ക്ലാസ് കൈകാര്യം ചെയ്യുന്ന ഡോക്ടർ കെ ജോസ്, കാലടി കോളേജിലെയും BCM കോളേജിലെയും സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ അധ്യാപകർ, ഈ വെബിനാറിന്റെ കോർഡിനേറ്റർ പ്രവർത്തിക്കുന്ന എബിൻ ജോൺ സാറ്, മറ്റ് അധ്യാപകരെ, ഈ വെബിനാറിൽ പങ്കെടുത്തുകൊണ്ടിരിക്കുന്ന വിദ്യാർത്ഥിനികൾ. കോളേജിനെ സംബന്ധിച്ചിടത്തോളം ഒരു സന്തോഷമുള്ള കാര്യമാണ് ഇങ്ങനെയുള്ള വെബിനാറുകൾ സംഘടിപ്പിക്കുന്നത്. ഈ കോവിഡ് കാലയളവിൽ ഇങ്ങനെയുള്ള വെബിനാറുകൾക്ക് ഏറ്റവും പ്രാധാന്യം അർഹിക്കുന്ന കാര്യവുമാണ്. സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിനെ സംബന്ധിച്ചിടത്തോളം പറയുമ്പോൾ കാലങ്ങൾ അടുക്കുംതോറും കൂടുതൽ പ്രാധാന്യം സ്റ്റാറ്റിസ്റ്റിക്സ് മേഖലയിൽ ഉണ്ടാകുന്നു. ഈ മേഖലയ്ക്ക് ഏത് മേഖലയാണെങ്കിലും അതിൻ്റെ ഉയർച്ചയ്ക്ക് മറ്റ് കാലങ്ങളെ പറ്റിയും അല്ലെങ്കിൽ മറ്റ് കാര്യങ്ങളെ കുറിച്ചുള്ള കമ്പാരിസൺ ഏറ്റവും ആവശ്യമുള്ള ഒരു കാര്യമാണ്. വിവിധ മേഖലകളിൽ പ്രത്യേകിച്ച് ബിസിനസ്, ഇൻഡസ്ട്രി, അഗ്രികൾച്ചർ, ഗവൺമെന്റ് സെക്ടറിലും പ്രൈവറ്റ് സെക്ടറും ഹെൽത്ത് ഡിപ്പാർട്ട്മെന്റുകളിൽ ഒക്കെ ഈ സ്റ്റാറ്റിസ്റ്റിക്സിന്റെ ഉപയോഗം അല്ലെങ്കിൽ ഡേറ്റാസിന്റെ കളക്ഷനും അതിന്റെ ഇന്റർപ്രിട്ടേഷനും ഒക്കെ ആവശ്യമുള്ള ഒരു കാര്യമാണ്. ഏത് പൊതു പ്രവർത്തനങ്ങൾ നടത്തണമെങ്കിലും അതിനൊരു പ്ലാനിങ് ഉണ്ടാകണം. പ്ലാനിങ് നടത്തണമെങ്കിൽ അതിന് വേണ്ട ആലോചനകൾ, കഴിഞ്ഞ കാലങ്ങളിൽ ഉണ്ടായ പ്രവർത്തനങ്ങൾ, വരും കാലങ്ങളിൽ അതിനുണ്ടാകാവുന്ന സാധ്യതകൾ, ഇതെല്ലാം മനസ്സിലാക്കിക്കൊണ്ട് മാത്രമേ ഏത് പ്രവർത്തനങ്ങളും നന്നായി നടത്തുവാൻ സാധിക്കൂ. ഇതിനെല്ലാം സ്റ്റാറ്റിസ്റ്റിക്സിനെ ഒഴിവാക്കിക്കൊണ്ട് ഒരു കാര്യവും ഞാൻ പറഞ്ഞ കാര്യങ്ങളെ നടത്തുവാൻ സാധ്യമല്ല. ഏത് കാര്യങ്ങളെ കുറിച്ച് ആലോചിക്കുമ്പോഴും അതിന്റെ ഫണ്ടിങ്ങും പ്രോജക്റ്റുകളും അല്ലെങ്കിൽ പ്രവർത്തനങ്ങളും ഒക്കെ എത്രത്തോളം ആകുമെന്നുള്ള പ്ലാനിങ് നടത്തുന്നതിന് ഏറ്റവും പ്രാധാന്യം അതിലെ കണക്കുകൾ അല്ലെങ്കിൽ സ്റ്റാറ്റിസ്റ്റിക്സിന്റെ ഡേറ്റ കളക്ഷനും അനാലിസിസും ഒക്കെയാണ്. ആ പ്രവർത്തനങ്ങളൊക്കെ ചെയ്യുന്നത് സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ നേതൃത്വത്തിലാണ്. നമ്മൾക്കൊക്കെ അറിയാം, വ്യവസായമാണെങ്കിലും ജനക്ഷേമ പ്രവർത്തനങ്ങളാണെങ്കിലും എല്ലാം സ്റ്റാറ്റിസ്റ്റിക്സിന്റെ സഹായത്തോടു കൂടി മാത്രമേ നമ്മൾക്ക് ചെയ്യുവാൻ സാധിക്കുകയുള്ളൂ. അനാലിസിസ് എന്ന് പറയുന്നത് ഇപ്പോൾ ഏറ്റവും പ്രാധാന്യം ഉള്ള ഒരു വിഷയമാണ്. ജോലി സാധ്യതകൾ ഏറ്റവും കൂടുതൽ ഉള്ള ഒരു മേഖലയുമാണ്. അതുകൊണ്ട് തന്നെ സ്റ്റാറ്റിസ്റ്റിക്സിന്റെ ഡിപ്പാർട്ട്മെന്റിന്റെ ആ മേഖലയ്ക്ക് ധാരാളം പ്രാധാന്യമുണ്ട്. ഇന്ന് ഈ വെബിനാർ സംഘടിപ്പിക്കുന്നത് സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റ് അല്ലെങ്കിൽ കരിയർ ഓപ്പർച്യൂണിറ്റീസ് ആൻഡ് ആപ്ലിക്കേഷൻ ഓഫ് സ്റ്റാറ്റിസ്റ്റിക്സ് എന്ന വിഷയത്തെ കുറിച്ചാണ്. കരിയർ ഓപ്പർച്യൂണിറ്റീസ് പറയുമ്പോൾ മറ്റെല്ലാ മേഖലകളിലേക്കാട്ടിൽ കൂടുതൽ ഇപ്പോൾ സാധ്യത ഉള്ളത് ഈ സ്റ്റാറ്റിസ്റ്റിക്സ് മേഖലകൾക്കാണ് എന്നതിൽ യാതൊരു സംശയവുമില്ല. അതോടൊപ്പം തന്നെ ഇതിന്റെ ആപ്ലിക്കേഷൻസ്, കളക്ഷന് ഓഫ് ഡേറ്റാസ്, അനാലിസിസ്, അതിന്റെ ക്ലാസിഫിക്കേഷൻ, ഇന്റർപ്രിട്ടേഷൻ ഒക്കെ ഇതിന്റെ വിഭാഗങ്ങളാണ്. അതുകൊണ്ട് തന്നെ ഈ മേഖലയ്ക്ക് അതിൻ്റെതായ പ്രാധാന്യമുണ്ട്. ഈ സമയത്ത് ഇങ്ങനെയുള്ള ഒരു വെബിനാർ സംഘടിപ്പിക്കുന്ന സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിനെ ഞാൻ അനുമോദിക്കുകയാണ്. അതോടൊപ്പം തന്നെ അതിനെ കോർഡിനേറ്റ് ചെയ്യുന്ന കാലടി ശ്രീശങ്കര കോളേജിനെയും BCM കോളേജിനെയും ഒന്നിച്ചു ചേർന്നുകൊണ്ടാണ് ഈ വെബിനാർ സംഘടിപ്പിക്കുന്നതിൽ വേണ്ട സഹായങ്ങൾ ചെയ്യുന്നത്. ആ ഡിപ്പാർട്ട്മെന്റിനെ ഞാൻ ഈ സമയത്ത് അവരോടുള്ള നന്ദി അറിയിക്കുന്നു. തീർച്ചയായും ഈ വെബിനാറിൽ പങ്കെടുക്കുന്ന വിദ്യാർത്ഥികൾക്ക് ഈ വെബിനാർ വളരെ സഹായകരം ആകും എന്ന് ഞാൻ കരുതുന്നു. പ്രത്യേകിച്ച് സ്റ്റാറ്റിസ്റ്റിക്സ് പഠിക്കുന്ന വിദ്യാർത്ഥികൾക്ക് അവർക്ക് വരുവാനുള്ള സാധ്യതകൾ കൂടുതൽ മനസ്സിലാക്കുവാനും കൂടുതൽ നന്നായി പഠിക്കുവാനും ഒക്കെ ഈ വെബിനാറുകളുടെ സഹായിക്കും എന്നതിൽ സംശയമില്ല. എല്ലാ ആശംസകളും, കോളേജിന്റെ പേരിലുള്ള ആശംസകളും നേർന്നുകൊണ്ട് എന്റെ വാക്കുകൾ ചുരുക്കുന്നു. നന്ദി, നമസ്കാരം.
Thank you so much, sir.
Dr. K.K. Jose, an august scholar, a keen statistician, an idol of knowledge and inspiration to all, to take up the session, Career Opportunities and Applications of Statistics.
Good afternoon. So first of all, I congratulate the managements of all the three colleges. That is actually St. Thomas College, Kottayam, Sree Sankara College, Kalady, and BCM College, Kottayam, to take initiatives to start this program in MSc Statistics this year. Very much grateful to Miss Professor Lizzie George, Ebin John, then Benno Matthew, Dr. Steffi Thomas, and other faculty members for taking pains to start such a program. Certainly it is a difficult task. However, so the students who have joined, they will be benefiting very much from this course, certainly, this program. So that is why the government of Kerala is giving more prominence to statistics and data-related courses. So, you know, even though this year a number of courses were begun, actually more importance was given to statistics, data science, and data analytics courses. So that actually shows the importance of this area. This is an emerging area. So I congratulate all the students who have joined for this program, for this MSc program in the three colleges. Certainly you will be benefiting from this. So what is needed is actually you should have a very cooperative or very what you can say, very receptive mind to study hardly or to do hard work, to know about the deeper subjects, so to work hard for acquiring this knowledge. So that is actually what I want to say as introduction. So I will be coming to the topic, and today I will be discussing on career opportunities and applications of statistics. I think Dr. Ebin will display, and I will just describe. So, hello, Ebin sir. Now you can display. Okay.
Display on ആക്കിട്ടുണ്ട് sir.
Okay. It's okay. So students can see. Students, you can see.
Okay, sir.
No problem. So the topic is career opportunities and applications of statistics. Certainly, I will be starting with the very basic definition of statistics actually. So next slide. So what is actually statistics? Next one. So what is statistics? So statistics, so you have already studied in your BSc classes or in your +2 classes. It is a body of methods for making wise decisions in the face of uncertainty based on systematically collected data and calculated risk. And for that, actually, we develop statistical models and statistical techniques. So statistics is concerned with a body of methods. Body means a number of methods for making wise decisions. And the purpose is actually to make wise decisions. Why? In the face of uncertainty. So everywhere you are faced with uncertainty. So that is why you are going to make wise decisions. How these wise decisions are taken, that is based on systematically collected data and calculated risk. Risk is actually calculated in terms of probabilities. So we will be coming to that. And for that, we develop different statistical techniques, different statistical models, different statistical distributions, different statistical analysis techniques. All these actually constitute what is statistics. So I will start with the basic definition of statistical data. So what is a statistical data? A statistical data is an aggregate of facts collected according to a well-planned procedure with reasonable standards of accuracy and precision and placed in relation to one another. It is actually the raw material of any statistician. So statistical data is an aggregate of facts. It is not isolated numbers. It is an aggregate of facts collected according to a well-planned procedure. There should be some planning behind that, and with reasonable standards of accuracy and precision. So whether it is given in centimeters, etc., then what is the precision? So all these things you have to predetermine and then placed in relation to one another. So the observations are related also. Related means suppose you are concerned with the marks of students in a class. So there is some relationship, that is, this is actually the marks of students in a particular class. Suppose you are concerned with income data or national income data, or suppose you are concerned with your monthly income data. So that may be the monthly income of persons in Kolanjeri or in Kottayam Taluk or in Kottayam district. So some such a relationship is there, should not be isolated. It is actually the raw material for any statistician. So that is what I want to say. For a statistician, the raw material is actually statistical data. So that is actually one of the most important things. So now, why we are using these? So because of randomness. That is actually the next slide. So everywhere in our life, we are always more concerned with the randomness and uncertainty in our life. So we are faced with randomness. When you are writing an examination, certainly you are having some uncertainty. So when you are concerned with the climate, certainly there is uncertainty. When you are concerned with your income, when you are concerned with some disease, everywhere there is uncertainty. So that is actually uncertainty, and something is random also. So even though we can expect something, so nothing is sure. So randomness actually means non-deterministic or lack of any systematic behavior without any order, so that we cannot make a prediction regarding what is going to happen in the next day, what is going to happen in the next trial. So that is actually what is meant by randomness. Uncertainty means unsure, not sure, not predictable with certainty. So we cannot predict we cannot say what will happen next. So that is actually the thing. So if we toss a coin, so we can say the outcomes are head and tail, but what will happen, that is random, that is uncertain. This can be used for studying dichotomous situations. So the coin tossing experiment is an example for experiments or situations having only two possible outcomes. So in all such situations, this coin tossing experiment is a simplification, so which we can just study in your classrooms. So certainly that simple experiment will can generalize to any dichotomous situation. That is actually what is explained here. So come to the next slide. So quantifying uncertainty. So everywhere we are concerned with uncertainty, and now we have to quantify that. So how you have to measure that? Suppose you want to measure your height or weight, so there is actually some procedure. So height is measured in centimeters or in meters or in feet. Then weight we can obtain in a weighing machine, so in kilograms or pounds, etc. But how to quantify uncertainty? How to calculate the chance of rain tomorrow? how to find the chance for COVID tomorrow. Suppose one of you have a chance of COVID-19. What is the probability that, so when you are coming out of your house to the college, what is the probability that you may get COVID-19? So if there is a high probability, your parents may not advise you to go to the college. So what is the chance of rain tomorrow in Kochi, rain tomorrow in Kolancheri, rain tomorrow in Kolancheri, or rain tomorrow in Kottayam? So all these are actually uncertain things. Chance of getting an A grade in an examination. And all this can be expressed in terms of probability. So probability is a measure of uncertainty. And as you know, probability lies between 0 and 1. If the event is an impossible one, then the probability is 0. And if the event is a sure one, the probability is 1. All these are actually something which you have already known, or which already you have studied in your degree classes. So there are different measures. There are different methods for measuring or quantifying this. And that is actually to obtain probability, to compute probability. And the simplest one, or the classical one, that is the classical approach or the mathematical approach, gives you Laplace. It was developed during the 1812 or 18, that is actually the 18th century, you can say. So that way, so here we assume that, so as you know, classical approach is actually based on the assumption of equally likely, mutually exclusive and exhaustive outcomes. I don't want to explain this. Equally likely means equal chance. So in the case of coin tossing experiment, you have equal chance for head and tail. Mutually exclusive means the occurrence of one will exclude the other. So if head occurs, tail will not occur. So in a die tossing experiment, we are having 1, 2, 3, 4, 5, 6. These are the phases. So all the phases are equally likely. If one occurs, the other phases cannot occur. If 2 occurs, other phases cannot occur. That is it. So exhaustiveness means you have listed all possibilities. So 1, 2, 3, 4, 5, 6. These are the possible outcomes when a die is tossed. So that actually, only that possibility is there. So it cannot revolve on its edges. Equally likely so. That is actually the situation of exhaustiveness. So we have to list out all possibilities. Suppose you are concerned with a birth, a delivery. So in that case, there may be a chance for male or female. So if you say male and female are the exhaustive outcomes, any other possibility is not at all counted. So suppose you are having a third sex child. So if you want to include that, you have to say the possible outcomes are male, female, and what you can say, the third sex, you can say. That is actually the thing. So we cannot say head and tail are the exhaustive outcomes. We cannot say male and female are the exhaustive outcomes. So if you say, you will be counting only those two. That is exactly. So once you have listed out all the outcomes, and if they are equally likely, mutually exclusive, and exhaustive, then only you can make use of this classical definition or classical approach. And in that case, you know, the probability of that event is defined as PA equal to NA divided by N, where NA is the number of outcomes favorable to A, and N is the total number of all possible outcomes. And very clearly, that is actually probability of an event is equal to the number of favorable outcomes divided by the total number of favorable outcomes. So what is an outcome? Outcome means what you can see. When these are actually very simple things which you have studied in your even +2 classes. Even then, it is to be clear. So a classical approach or the mathematical approach is based on these 3 assumptions of equally likeliness, mutually exclusiveness, and exhaustiveness. Then very clearly PA lies between 0 and 1, but all the assumptions may not be true always. So suppose you are concerned with the sex of a child. So in that case, male and female are not equally likely outcomes. So in Kerala, there is a chance for more female. But if you go to Haryana or Punjab, there is a more chance for male child. Why it is so? There may be some unnatural interventions from the parents, from the doctors, etc. So Kerala, so there is a high chance for, there is a slightly more chance for females, since we are not at all concerned with other artificial things. So that is actually the peculiarity. So, and there is a third sex, transgender. There is also a chance for that. So in this case, male, female, and transgender, you can say they are not equally likely. So we cannot make use of this classical approach to find the probability. So that is why we are going to the other approach, that is actually the frequency approach. Next. Go forward. Okay. So the frequency approach is actually something which is independent of any assumptions. And this is due to von Mises. So von Mises, that is actually by the same the same time as that of Laplace, you can say. So in between Laplace and Kolmogorov. So we will be coming to that. So after 1812 or after 1850s, this frequency approach came. This gives a practical method for computing probability. And this actually referred to as the empirical approach or the statistical approach. Here we repeat the experiment. Here we conduct the random experiment a number of times. Suppose the random experiment is repeated 10 times. Then we are counting the number of trials in which the event A has occurred. So number of trials which are favorable to A and denoted by NA. Then the relative frequency RA is equal to NA divided by N. So here NA, that is the number of trials in which A has occurred, divided by the total number of trials. It is not outcomes. So here we are not concerned with outcomes. So how many times the event has occurred divided by the how many times the experiment was conducted, NA divided by N. That can be taken as an approximate value of probability of A. So if you want to get a good approximate value, you have to repeat many number of times. So if you repeat the experiment very large number of times, then we get a more accurate approximate value of PA. So we cannot obtain the actual value. So even if you repeat it 10,000 times, you are getting a more accurate approximate value. So if you conduct the experiment, say 1 lakh times, then you have got a more accurate approximate value, only that much. So here, what shows certainly PA lies between 0 and 1. So as far as the frequency approach is concerned, we cannot obtain the exact probability. But we are getting, you can improve the accuracy of the estimate of probability of A. That is another thing. So certainly the frequency approach is based on something called law of statistical regularity. So also you have studied in your degree classes. This law states that in spite of the irregular behavior in individual trials, there is a regularity that the relative frequencies converge to a fixed value. This value is taken as the probability for the event. This is assured by the strong law of large numbers. It is the basis of frequency approach. So what I want to say is, so whether these relative frequencies will converge to a particular value, certainly it is assured. It is assured by strong law of large numbers. So weak law of large numbers, etc. You have studied. So it is the basis of frequency approach, and that is actually depending on what is known as the law of statistical regularity, irrespective of the regular behavior in individual trials. There is it is sure that there will be a regular behavior, that is the relative frequencies will converge to a fixed constant, and that fixed constant is defined as probability of A. That is why we say PA is equal to limit as n tending to infinity of this R A, that is the relative frequency of E. Now we will be coming to the next one. That is actually known as the quantum probability. Quantum probability also is the next one. Axiomatic probability. No. Just one slide below. Axiomatic. So axiomatic approach, it was actually due to the famous mathematician A.N. Kolmogorov, who was a Russian mathematician. So it was actually developed in 1933. Actually, the classical definition and frequency definition received much criticism from mathematicians. So from mathematicians' side, it had no basis. Now, Kolmogorov was trying to give some basis for probability theory. And he actually made use of measure theory. So measure approach, that is why it is usually referred to as measure approach. And it was developed only in 1933, very recently, just before 100 years, just 90 years or even less than that. This gives a mathematical foundation to probability in terms of set functions. So you have studied this definition. So PA is a set function. It's a measure satisfying the axioms. 3 axioms. One is PA is always greater than or equal to 0. probability of sample space is equal to 1, or probability the null event is equal to 0.
സാറിന്റെ
So using these three conditions, you can develop the whole theory of probability, or the addition theorem, the multiplication theorem, everything you can develop using these three conditions. Then whatever you study, whatever things you study in probability theory, that is actually a development of these three axioms. Remember that. Now we will be coming to one more definition, that is the next one. That is the quantum probability. So quantum probability, that is not much studied in our classes, but in physics classes, they are studying quantum probability. Quantum probability was actually developed using the frequency approach of von Mises and measure approach of Kolmogorov. It was developed during the 1940s, you can say. So it is actually the basis of quantum mechanics in statistical physics. In physics, there is quantum mechanics. So actually, quantum probability was developed by statisticians or probabilists to accommodate quantum mechanics. So even physicians like Einstein also worked with it. So von Neumann was actually the person who developed this one. So quantum theory, as non-classical probability theory, was incorporated as non-commutative measure theory by von Neumann in the early 30s as well. This type of this approach was there, but it was formally developed by physicists actually. It is used to explain the foundations of quantum theory in quantum mechanics. It is used in statistical physics, so not much used by statisticians or mathematicians, but in physics they are actually making use of this one. The next one, subjective approach. So subjective approach is due to Bayes. It's actually an after effect of Bayes' theorem. So it is called subjective why. It actually uses prior data or prior information along with information from sample data to compute posterior probability. It is subjective since it depends on personal experience. So it can change from person to person. So the person having more experience, he will be giving a better subjective probability. So it may change from person to person. A more experienced person give more reliable prediction. With modern computational facilities, this approach is widely used. It is used in disease diagnosis, criminal investigations, etc. So as far as the subjective approach is concerned, it is just like consulting a doctor. A doctor having good experience, certainly he will be giving a very accurate prediction or a very accurate decision about the disease. So next slide. Next. So it was actually Reverend Thomas Bayes who developed this result, and it is actually based on his Bayes' theorem. So Bayes presented his theorem in the Royal Statistical Society of London during 1736. Actually, it received much criticism as an utopian concept, an impractical concept. So it actually received much severe criticism. People say it is actually utopian, it is something which is mad. So Bayes is not at all a normal. So he was a priest actually. Thomas Bayes was a Presbyterian priest actually. So he received but they cannot find any fault with his theory. The theory was okay, but how it could be implemented, that was actually the problem. So how to find the posterior probabilities, how to find the prior probabilities, all these were complicated things. It is not at all possible, it is not at all practical. So that was the criticism. Even then, he was awarded FRSS, Fellow of the Royal Statistical Society. He was awarded in this FRSS in 1742. So even though they approved his theory, it could not be practiced actually. That was actually difficulty. His research findings were rediscovered and published only in 1763, 3 years after his death. Only after his death, some of his relatives actually published this in 1763, after 2 years. So it received serious attention only during 1960s with the introduction of computers. So when computations become feasible, certainly the Bayes approach or the subjective approach came into prominence. Now it is referred to as Bayesian inference. So now in statistics, the present era is called the era of Bayesian inference. So mostly, so even before data science or data analytics, etc. So the present day statistics, so they were more concerned with Bayesian inference. So that is why people in the modern subjects in statistics or data science, data analytics, they are all studying Bayesian computing. So Bayesian inference has revolutionized statistics actually. Now comes to fuzzy probability. Fuzzy probability, that is also something very recent. So that was actually developed by a famous mathematician. It is not, it is along with the probability. So one has in mind a measure of fuzziness also. Now you say there is light during 6 o'clock, 6 a.m. There is light during 10 o'clock. There is more light during 12 noon or so in the noon session, noon time. There is light during 3 o'clock. There is light during 5 o'clock. There is light during 6:30. So certainly there is some difference. By 6 a.m. early morning, the light is very mild. So by evening 6:30, the light is very mild. But during 12:30 or 1 o'clock, the mid-noon, so when you are out for lunch, certainly there is more light. Similarly, so when you say about rain, the rain may be a mild rain, a strong rain, heavy rains, all these are actually there. So, along with the probabilities, what is the probability for rain today? This is a very casual question. What is the probability for heavy rains today? That is a more accurate question. What is the probability for very mild rain? So these are actually things which are measured by fuzzy probability. It's not just a crisp probability. It may be a probability range. So when you say the probability is 0.70, it does not exactly mean there is 70%. It's actually something between 0.65 to 0.74, etc. So it depends on the degree of truth based on the data. It differentiates between the levels of truth. Next one. So fuzzy probability and crisp probability. There is a meaning. Suppose you are tossing a die. So if you are tossing a die, the probability that a fair die will show 6 is 1 by 6. That is always 1 by 6. There is no change. This is a crisp probability. That is accurate, exact probability. It is referred to as crisp probability. All credible mathematicians will agree on this exact number. Now suppose another question is there. A meteorologist forecast the probability for rain tomorrow as 0.70%. It is actually a fuzzy probability. So more realistically, it is a fuzzy probability. There is not any chance for exactly 70% chance. Using the same weather data, another meteorologist will typically announce the probability is 0.75 or 75%. Another person may say it is 60%. So all are having some such idea. There is a good probability for rain tomorrow, only that much. So it depends on the strength of the data. So if you say the probability is 99%, so certainly it is a stronger one. There is a stronger chance. If you say the probability is 20%, certainly it is a weaker one. So that is like the difference between a fuzzy probability. A fuzzy probability of 70% actually means it is something in between say 60 to 75 or something, some in a range. You can say it is not an exact one. So next one. So now we are coming to statistical modeling. So actually, what is the purpose of probability? Probability is actually to measure uncertainty. For that actually, so just like you have studied random variables after probability. So all these are actually concerned with developing or statistical models for describing reality. So what is actually statistical modeling? So science does not deal with reality, but with the models of reality. Everywhere in physics or chemistry, we are not exactly dealing with the reality. We are actually trying to model reality. Scientific study is to search for better models of reality, to explain the reality. Statistics also deals with the models. In physics or in chemistry, we have studied different relationships as well. That is actually to explain reality, to model reality. May not exactly happen. Even in chemistry, so hydrogen and oxygen, if they are clubbed together, if they are mixed, so certainly there should be a proportion, some well-defined proportion of mixing. Then only it will lead to water. Carbon dioxide, C plus O, that is carbon monoxide. C plus O2, that is carbon dioxide. So even if you mix carbon and oxygen, so it's actually giving different subjects. So that is actually the reality. So we are trying to model that. Scientific study is to search for better models of reality. Statistics also deals with models. So what you can say, model is a description of reality. Models are not equal to reality. It's usually a simplification of reality. And what is the purpose? It helps to understand reality. And a famous statistician says, called Box says, all models are wrong, but some are useful. Some are very useful also. So all models are wrong. No model is correct. All models are wrong, but they are useful. They are very useful. The suitability and complexity of models can depend on the purpose based on data, understanding, predictions. It is good when it is close to reality. That is actually what it is. Next one. So there are different types of models. So you have studied the gas equation, the ideal gas equation in physics, PV equal to RT. Even then, that has been modified. The demand law in economics, demand is a function of price, consumption function. Income and consumption are related. Consumption is a function of income. Keynesian model in economics, that is, income is equal to consumption plus investment. Relation between age and height, that is a regression model, y equal to a plus bx. Production model, to quantity produced, that is equal to a function of NLK, natural resources, labor, capital, etc. So this type of models are there in physics, chemistry, biology, economics, commerce, etc. In mathematics also. So we are having different types of models. But next one, some are probability models. So the binomial distribution, that is a model for dichotomous events. Poisson distribution, that is a model for rare events. Exponential distribution is a model for lifetimes. Normal distribution is a model for almost all types of data. All types of data means if there is sufficiently large number of observations. Log normal distribution, that is a model for income and wealth. So there are skewed models, symmetric models, positively skewed models, negatively skewed models. All those things are there. But there are some common models. But suppose you are given a particular data, certainly you cannot find an exact model for that. Certainly you will be approximating. So certainly you can improve the existing models, binomial distribution, Poisson distribution, etc. You can improve. That is how we develop new models actually. So now we are coming to stochastic models. Stochastic models are actually having some stochastic component. But in mathematics, people will say everything occurring in nature is according to mathematics. So suppose you are concerned with COVID. Suppose mathematicians are modeling COVID. They will use some equation. There is an exponential growth, so exponential function is suitable. But statisticians will say it's not exactly exponential. There may be some slight deviations. So in deterministic models, there is no randomness and the outcome is totally predictable. Consider a linear model, y equal to a plus bxi. So that is a linear model, that is a mathematical equation. But statistician will say no data will be strictly linear. All points will not fall on the same line. So stochastic models include both deterministic and random components. So what we consider, we will be considering a random component epsilon I, where epsilon I is normally distributed with the mean 0 and variance sigma square. So there may be some points may be above the line, some points may be below the line. So plus epsilon I. So it is actually from minus infinity to plus infinity, you can say in general, but slight deviations, etc. you can obtain. So that is actually why we make use of stochastic model yi equal to a plus bxi plus epsilon I. So you students have studied about Kerr fitting, the principle of least squares, etc. So this is the principle of least squares, you can fit this type. So there actually we are minimizing the error sum of squares or the residual sum of squares. That is actually the procedure by statisticians. Whereas a mathematician will not allow that. A mathematician will be just considering such a model and they are just approximating, they are just estimating and so on. So in mathematics, we cannot have some such procedures. Certainly they have to incorporate the statistical principles, etc. So statistical inference based on data. So there are stochastic models trying to quantify the role of chance. Any stochastic model can, in principle, be confronted with data. So in practice, what is done is actually we are having data And using this data, we can develop models, and that is actually stochastic models. Next comes to correlation and regression. Now, suppose you are having two variables. So, if you are having two variables, certainly you want actually to study about the relationship. So, correlation measures the degree of linear relationship between two variables, whereas regression describes the actual linear relationship between two variables. So, how they are linearly related? What is the equation? Whereas correlation is just a measure, just to quantify that relationship. So, when you say the correlation is +1, we know there is perfect positive correlation. When the correlation is -1, we say there is perfect negative correlation. When it is equal to 0, we say there is no linear correlation. When y equal to a plus bx is the regression line, so we are having the exact relationship provided the values of a and b are given. So that is actually what is done. And when you are having more than two variables, when we have more variables, we have partial correlation, multiple regression, and so on. There is non-linear regression also, polynomial regression also. All these are actually studied in advanced theory. So certainly, your students will be studying in regression analysis. That is a full paper for you. So there you will be studying about non-linear regression, polynomial regression, many things. So that is actually the importance of regression. Regression and correlation, that plays a prominent role in our study. Next one. Then a bit more than random variables. So we will be coming to stochastic processes also. So in the second or third semester, your students will be studying about stochastic process. So here we are having dynamic type of random variables, a family of random variables. So not just a random variable, a family of random variables. So it is actually denoted by xt omega. It depends on time or some indexing parameter, and omega is the sample point or the outcome. So it may, suppose you are concerned with the trajectory of a satellite. So as a satellite moves on, certainly there is some dynamism. So at the time of launching it, then it actually passes on to different stages. So even in the atmosphere also, different stages are there. The temperature in the land, that is not the same. As it goes up and down, the temperature is different. Then the wind velocity is different. Everything, the humidity level is different. So certainly the outcome also is different. It is actually a function of time as well as outcome. So that is actually what you mean by a family of random variables. And there is something called random walk processes. So certainly some movement of particles. So in such a case, you are having randomness, some random walk. Just like suppose you are having Brownian motion. So if suppose you are having some particle immersed in a liquid, certainly there is zigzag movements, Brownian motion or diffusion process, etc. So all this can be described using stochastic processes. So Markov processes. Markov process is actually something which depends on the previous value, which depends on the past. The future of the process depends only on the present, irrespective of the past. Then Poisson processes. All these are actually some stochastic models, some models which we can use for describing natural phenomena. I'm not describing all these things. You will be studying as part of your theory papers or stochastic processes. Is certainly a compulsory course for MSc statistics. Now we will be coming to the next one, empirical modeling. Now, empirical modeling in the present times, that is actually data-driven. So now, data-driven empirical modeling has become the rule actually. Application of statistical techniques is the data-driven. Methods are the probabilistic in nature. Certainly, short-term projections only, short-term forecasting only is possible. We cannot predict the price of rubber for next 12 years. We cannot say the number of persons who will die due to COVID during the next 5 years. We cannot say. We can predict for just for 1 week or just for 1 month maximum. Only that much. So that is only realistic. So remember, in data modeling, we can make only short-term projections or predictions. That will be exact. Others will be just giving some idea about the direction in which things are going on. Certainly, this actually received much criticism. Limitations are there. It requires reliable and representative data. So all our decisions are actually data-driven. So our decisions are depending on data actually, the quality of the data. Only what you can say is only the probability for chance for the occurrence. There is no surety. Statistical models cannot prove anything. Statistical models can give some insight. It helps like a torch to guide in darkness. It is giving just an insight, just like a torch in darkness. So remember that also. So even then, but everywhere if there is darkness, certainly a torch is very useful. Only that much. Next one. So why we are studying statistics? So now we are coming to the point. Why study statistics? So collecting data on subsets of population or samples can give valid information about the whole population. That has been proved theoretically as well as from practical experience. Knowing what has happened in the past can help answer questions about the present and future. Knowledge of past helps plan future threats, determine resource allocation, improves quality. All these are actually time-tested decisions or time-tested conclusions. So what has happened in the past, you observe through that. If you make use of a critical study of that, certainly you can predict about the future. You can have some valid predictions about the future. That is why we are studying about statistics. Why we study statistics. Next one. So what do statisticians study? So statisticians are studying about different things. I have just pointed out something. So we determine the effectiveness of new drugs. So now it is COVID season. So there are different types of medicines. The vaccine is there, then the shield, the COVID shield. So different vaccines are being developed, and we want to determine the effectiveness of these drugs. Suppose unemployment is there everywhere. Unemployment is there. Mortality is there. Estimate the unemployment rate, mortality rate, all those things. Consumer demand for products. Analyze the consumer demand. Then plan and analyze agricultural experiments, analysis of time series, business cycles, etc. Then biodiversity studies, statistical ecology. All these are actually some topics in statistics. Economic planning, financial planning, econometrics. All these are actually there. So you have to study these things. Then weather forecasting, pollution level, climate. You have to predict the climate. So all these things are there. So these are actually some of the works which your statisticians are more immersed. So we will be coming to details in the coming slides. Next. So I will, before coming in detail to statistics, just some idea about the foundations of modern statistics. Next one. So KARL Pearson is referred to as the father of the science of statistics, and it was actually he developed actually statistics. So you have studied Pearson's coefficient of skewness, Pearson's coefficient of kurtosis, all those things. Pearson's moments, many techniques you have studied. Then comes R.A.FISHER. R.A.FISHER is referred to as the father of modern statistics. So KARL Pearson is actually the father of the science of statistics. So even before that, statistics was there. There was population census during the Bible time. So we are concerned with the census time while Jesus was born. Then many ministers in India, you have studied about Ashoka, Chandragupta Maurya. All of them had very good statistical system in India. India is boasting about a very sound statistical system. Then actually everywhere there was actually statistics. So but it was made as science, something like a scientific subject. That was actually by KARL Pearson, and it was R.A.FISHER who revolutionized it. He made it modern statistics, making use of mathematical foundations. Then came Indian statisticians and Professor Mahalanobis and C.R.Rao. Next one. So as far as Professor Mahalanobis is concerned, Professor Mahalanobis, so we will be just concerned our Indian statistician. Professor P.C.Mahalanobis is widely known as the father of modern statistics. Remember, he was born on 29th of June 1893. So that is why 29th June is always celebrated as National Statistics Day. Every year in India, 29th of June is celebrated as National Statistics Day. Mahalanobis was a physics professor, remember. He was a physics professor in the Presidency College, Calcutta, which was actually developed as the Presidency University. So he was a physics professor. He was head of the Department of Statistics actually. So he is referred to as a physics professor by career, a statistician by instinct, and an economist by conviction. And that is actually what C.R.Rao says. So what was his aim? The aim of statistics is human welfare. That is what he said. He was the founder of the Indian Statistical Institute in 1933. The Statistical Institute was actually founded on the veranda of the Department of Physics of Presidency College in 1933. It was actually, the registered office was the head of the department's office, the office of the head of the Department of Physics actually. So later, Professor Mahalanobis became the principal of that college, and only at that stage, it was given an office room. So the Indian Statistical Institute was actually founded in the Presidency College, Calcutta in 1933, and it was in the office of the head of the Department of Physics. He was the head of the Department of Physics. When he became the principal of that college, he allotted a room for the Statistical Institute. His main contribution, so that is actually the story. So all of you can go through these stories. So his main contributions are Mahalanobis distance function and so on. And he actually not only developed some contributions in statistics, he was actually an economist also. He was actually a member of the planning commission also. He was actually some person, he dealt with blood control measures, food packets, acceptance sampling, all those things. According to Professor Mahalanobis, statistics is the new technology for scientific advancement and national development. Now comes C.R.Rao. C.R.Rao was born in 10th September 1920. So this year, last September 1920, he completed 100 years. He is even living. He is a living legend. So last September 10, we celebrated the 100th birth centenary of Professor C.R.Rao. He is the leading statistician all over the world for more than 5 decades. For the last 50 or 60 years, he is the leading topmost statistician in the world. He passed MA Mathematics in 1944, and with that he could not get a job during 1940s. Actually, he went to Calcutta for studying MA Statistics in 1943. And he received PhD from Cambridge University under R.A.FISHER in 1948. He contributed immensely to statistics. So Kramer-Rao inequality, Rao-Blackwell theorem, etc. You will be studying as part of your MSc course. This year, we are celebrating his birth centenary. He is referred to as a living legend. For him, statistics was the last resort. So with his MSc Mathematics, MA Mathematics, he could not get a job. So lastly, to get a job, he actually studied statistics. That is what he says in his biography. So P.V. Sugatme and S.R.S. Varadhan are also some other statisticians, Indian statisticians. And Sugatme is a nutrition, whereas Varadhan was a student of C.R.Rao. S.R.S. Varadhan, he is usually referred to as a mathematician, but he was a statistics student. He was a student of C.R.Rao. So P.V. Sugatme, next one. P.V. Sugatme was born on 27th July 1911 in Sankara, Maharashtra, and he received a PhD in 1938 from University College, London. He worked in ICIR, Indian Council for Agricultural Research, and founded Indian Agricultural Statistical Research Institute, IASRI, and the Indian Society of Agricultural Statistics. So he was actually more concerned with agriculture. So he was chief of Statistics Division, the Food and Agricultural Office of United Nations at Rome. So FAO, you might have studied about the different organs of UN in your high school classes. FAO is one of the most important organs of UN. This year, the Nobel Prize was won by FAO. He was actually the chief of Statistics Division in FAO of UN at Rome for 18 years, from 1950 to 70. So he was actually one person who influenced statistics all over the world. So he is remembered as an agricultural statistician and nutrition. So Sugatme Morgan hypothesis on nutrition is very famous. He founded Maharashtra Association for Cultivation of Science. He actually saved millions of people from this famine in which occurred in Maharashtra during the 1950s. Next one. Some other Indian statisticians. Living Indian statisticians are R.R. Bahadur, D. Basu, Usarba sir, K.R. Nair and K.C.S. Pillai are Indian Malayali statisticians. From Kerala, K.R. Nair and K.C.S. Pillai. Then T. Kaila, Thomas Kaila, U.S. Nair, A. Mattai, Bhavas Abraham. Bhavas Abraham is from Kolancheri. So he's from Ramni actually. He's from Ramni. So he's one of the leading statisticians all over the world. He is now in Canada. Professor A. Mattai, he is from Pala area. So he is also in Canada. Thomas Kaila, he has received the topmost prize along with Dr. C.R.Rao for contributions in statistics and signal theory. He was actually in communication engineering. He was actually a statistician turned communication engineer in communication engineering. So they are studying stochastic process in the name signal processing. Signal processing is nothing but stochastic processes. So Thomas Kailath has contributed significant contributions. R.C. Bose, Meghnad Saga, etc. contributed to statistical applications in physics, chemistry, etc. Now, this is actually lady testing experiment. This is one of the famous stories in statistics, which actually led to the development of statistics. Lady testing, there is a lady in between. So they had, so in next slide, you can come to that. So the challenge of a lady. So it was during 1920s. So Cambridge, the London University College, London. Every afternoon there was a tea party in the university department at 3 o'clock, you can say. And one day, this lady was saying, I can tell whether milk is poured first and the tea is added next, or whether the tea is poured first and the milk is added to the tea. So many of you are ladies attending this conference, this seminar. So you people prepare tea, whether milk is added to the tea or tea is added to the milk. So can you just say by tasting a cup of tea? So this lady was playing that way, but there was R.A.FISHER. Next slide. R.A.FISHER was there in that. And Sir Ronald Aylmer Fisher, R.A.FISHER, his full name is Ronald Aylmer Fisher. He was a British statistician. He is referred to as the mother of modern statistics. He is actually referred to as the most influential statistician. He was there with them. So he actually developed these concepts of randomization, variance, null hypothesis, maximum likelihood, all these things in statistics. He almost single-handedly created the foundations of modern statistics. So actually, that is actually the history. So he developed modern statistics alone. Now come to the next slide. So what actually, the lady was actually just saying as a fun. So what she said, I can just tell with this cup whether this tea is added to milk or milk is added to tea. But what Fisher actually prepared 8 cups of tea. So the lady was just only thinking about only one. Sometimes it may be true or may be false. But Fisher prepared 8 cups of tea. He prepared by his own. In some tea, he poured milk. In some cups, he poured milk first, then tea second. So that way, there was some randomness, random order. So he could identify. He put some mark on the bottom of the cup. Then have the lady taste them and make her decision. Actually, this was the foundation of any research work. So this led to the principles of randomization and replication. Randomization means random order. Some randomly arranged. So you have to randomly allot the treatments. Then replication cannot just make use of, or you cannot arrive at a decision with just one. You have to repeat it. Replication means repetitions. So here he used 8 cups of tea, and using that he arrived at the conclusion whether the lady's claim is correct or not. And fortunately, the lady was correct actually. That is the history. So many of the students who are attending this, so you can just mark a lady testing the tea experiment in the Google. You can get enough number of papers. You can get enough number of books. A lot of books have been there on this one, lady testing the tea experiment. So it has been discussed a very large number of times everywhere in science. This actually led to what is known as designing of experiments. This actually led to the grammar of science, the grammar of research. So research is actually making use of this one. So every research we want repetitions. In physics lab or chemistry lab, you are repeating the experiment. Why? So to avoid randomness, to avoid random fluctuations, changes, fluctuations, accidental fluctuations, etc. So why we need actually? So then only you can estimate variance. Only with one observation we cannot estimate variance. There is no change. Only with more than one observation we can obtain variance and so on. So that is why lady testing the tea experiment became one of the most prominent experiments in science. Now come to the next one. So why statistics? So that is actually a question which was put forward by Mahalanobis. Why statistics? Statistics is the new technology for economic planning and development. It is the new science of decision making. Statistics directs new developments in scientific research. The modern era is data driven and all decisions are data driven. Data is very powerful and can give more insights about the system dynamics. The dynamics of the system. Suppose you want to study about COVID data, COVID movement, COVID growth, etc. So certainly you have to collect data. Then only you will be able to understand the dynamics of the system, the COVID system, how the COVID is spreading. So that is for that you have to get data. Suppose you want to study about our economy, certainly you have to collect data. You have to analyze that. So how the economy is going on. So all those things everywhere, even in these scientific explorations. So even in science, space research, etc. They are using statistics. They are using data, and they will be analyzing this data, and they will be arriving at conclusions. Now I will be speeding up. The raw material for a statistician is data. So it may be a supervised data or unsupervised data. Unsupervised. So in the present era, we are having unsupervised data also. The present era is that of big data. Unsupervised means some information or some data which can be traced from this Facebook, social media, from your email, from your SMS, etc. So we can get data. We can extract data from your emails. So even the security persons are observing your emails, observing your involvement in social media. All these are actually unsupervised data. Whereas supervised data, that is the original statistical data, which has been collected according to some systematic standards of accuracy and precision. So now in the present era, we have big data. It is not systematically collected, but it contains information. And the statistician's role is to extract information from that. Data warehousing and data mining are necessary for that. That is, all this data are to be stored. Then you have to collect good data, exactly required data from this warehouse. Computer programs are needed. Data quality is important. Data cleaning is essential. All these are actually done by the present day data science people, data analytics people. Certainly, the basis is statistics, or statisticians are the people who are helping forward. So key questions in developing a model. So next one. So in developing a model, we have to answer all these things. What is the health problem? So suppose you are concerned with COVID disease. So what is the problem of disease condition, manifestation, character? What? Who is affected by this COVID more? Whether with youngsters, whether with the children, whether with old people, whether with the middle-aged people, whether with males, females, sex, social status, ethnic group, all those things. Where does the disease occur? Whether it is in rural place, whether it is in urban places, whether it is in cities, or all those things. When does it happen? Whether there is anything regarding, say, season or years or months, whether it is more prominent in rainy season or hot season or summer season or winter season, all those things. How does the health problem or disease condition occur? All these things are there. Next one. So this actually gives a summary of summarizing the applications or the areas where statistics is used. So maybe in physical sciences, astronomy, chemistry, physics, space science, environment, agriculture, ecology, forestry, animal population, climate studies, in government, census, law, defense, official statistics, government planning, town planning, sports, etc. Then health and medicine, biostatistics, genetics, clinical trials, epidemiology, pharmacology, biometrics, etc. Business and commerce and management, economics, insurance, actuarial science, engineering, market research, computer science, econometrics, and so on. So this not complete actually. So this actually gives you an idea about different areas. So next one. So now I will be concluding it very speedily. So statistics is used in business and industry or industrial statistics, process control, etc. So you have heard about Six Sigma, capability indices, etc. So consumer satisfaction surveys, etc. All these are actually concerned with statistics. Next one, market research. In market research, we are actually concerned about the attitude of persons, the attitude of consumers, etc. So suppose you want to start a business, certainly you will be conducting this type of studies. Next one. Engineering. In engineering, we are studying about statistics, statistical reliability. Reliability is actually one of the most important topics. Then is actually stochastic process or signal processing. Then quality control, process control. They are studied by mechanical engineers, electronics engineers, then software engineers, etc. They are more concerned with reliability and all these things. Then comes to the next one, statistical computing, data analysis. So you will be studying in detail data analysis techniques. Next one. So this is actually something said by a statistician. I love that statistics is very multidisciplinary. A person involved in industry, it involves problem solving in a group environment, and it involves many skills and talents. I love ability to be a mathematician, computer science, teacher, quiz master, planner, consultant, and even devil's advocate. Devil's advocate means so you have to support. Suppose you are in the court, certainly you may be supporting that. You have to find data for that. All rolled into one. That is actually the statistician's job. So you should be a mathematician also. You should be a computer scientist also. You should be a teacher also. You should be a quiz master also. You should have some plans. You should be a planner, engineer also. You should have some consultancies. You should be ready for consultancy. All those things. So everything combined together, all rolled into one. That is technique. So now comes epidemiology or biostatistics. So statistics is used in health and medicine. Then it is referred to as epidemiology, biostatistics, etc. Say COVID, corona, all those things. So to conduct clinical trials, etc. We want actually these things. Next one. Public health and statistics. So to study about public health, prevent diseases, etc. So you have to study about, you have to collect data, community first, sanitation, hygiene, education, diagnosis, evidence-based medicine. So even this year is 2020 is actually the birth, the 200th year of Florence Nightingale. Florence Nightingale is referred to as the founder of public health statistics. So even though she was a nurse, she was actually a very celebrated statistician. She was the first lady to get to become the fellow of the Royal Statistical Society. So he was actually a fellow of the American Statistical Association. He was actually the person behind public health statistics actually. So what he developed was actually evidence-based medicine. Next one. Pharmacy or drug development, clinical trials, etc. are based on statistical things. So we have to plan and we have to develop design of experiments, etc. to develop new drugs, etc. So for that actually statistics is very used. Next one. So the present era, present day, so many of you might have heard about the genome project, etc. So here we are concerned about gene sequence modeling, genetic structures, etc. So this is actually one of the most important areas nowadays. Genomic studies. Genomic studies is based on statistics. So you have to identify the gene structure, the DNA structure, so genetic structure, etc. That is actually studied in biostatistics. So biostatistics students actually study about genome sequencing, the models for that. They are not much concerned about the biological aspects. That is actually done in the lab, but they are more concerned with the statistical models for this one. The next one. So this is actually what a medical student has said. Last year when I began applying for jobs in the cancer research and public health modeling, the fact that I majored in statistics was always a good point in interviews and made me more unique as an applicant. So many of you students can work in cancer research. So after your MSc statistics, certainly you can go to public health modeling, cancer research, AIDS modeling, COVID vaccine development, clinical trials, etc. So that is actually an area where it is widely used. Next is learning. Even in teaching and learning, statistics is widely used. So to develop new, so for B.Ed, so there is actually statistics. So in psychology, for studying about psychometrics, that is statistics actually. So different methods of teaching. So for studying about the efficiency of different methods of teaching, etc., you want statistics actually. New teaching methods, psychometrics, cognitive studies. That is actually another area where statistics is widely used. Next one, statistics, science writing and journalism. That is actually where, so you have to be a good scientist, so you have to write and publish. For that actually statistical data analysis is there. Every researcher actually makes use of statistical data analysis, and they are to be summarized, the conclusions are given. So in all such cases, so even in journalism, so if you are reporting some sports event, you have to study statistics, you have to know statistical methods, so you have to give diagrams, graphs, you have to give the summary figures, etc. Then only it will be reasonable, it will be more attractive. Then next, research, everywhere statistics is used, official statistics, then public opinion polls, policy making, planning, and so on. Even in courts, statistics are used. Drug approvals, statisticians are consulted. Public hearings, lobbying, argument. Indian Statistical Service, statistical investigators, enumerators, etc. They are actually doing research for government. So actually, it is based on policy research, their own decision makers. They are actually decision makers as far as the government is concerned. Next one. Survey methods. Survey methods, so everywhere they are conducting surveys, collecting data in the social science, education, law, forestry, agriculture, biology, medicine, economics, e-commerce, government. Everywhere we are actually making use of survey techniques. So to execute a project, simply you have to conduct a sample survey, then the data is to be collected. Sample survey is actually a compulsory paper for all of you. So you have to study sample surveys. So that actually gives you different methods of collecting data, survey methods. Next one. So this is also something which an engineer has said. I found that statistics is more reasoning and logic skills than the course I had previously taken. The more I did statistics, the more I like the alternative application of mathematics that it provided. I especially liked being able to use a lot of data and a little common sense to figure out problems. So that is actually the importance of statistics. It is actually having some logic, some reasoning. So it is actually having more applications. So now comes to law. So even in law cases, court cases, statisticians are concerned analyzing data about the DNA evidence, salary discrimination of lawsuits, disease clusters, quality checks, etc. Everywhere the statistics is used, statistical data is used. Statisticians' opinion is another is actually consultancy. So after completing your study, you can make use of this type of consultancy. You can offer consultancy to other people in pharmaceuticals, ecology, engineering, MBA, data analysis, quality checks. So that is actually offering data analysis and consultancy advices to others. Next is actually agriculture. So design of experiments is widely used. It's everywhere. So geology and so on. So we are actually making use of statistics actually. Rubber board, coconut board, spices board, etc. Employees, people. There are good statistics departments in all these departments. That comes to the next one. Ecology and biodiversity. That is actually you might have heard about tiger census. Every year, government is conducting tiger census every 2 years. Wildlife surveys, etc. Earth's natural resources, environment, animal population, agricultural protection, fertilizer, pesticide safety, etc. All these are actually more concerned. So in the now in the modern ages, modern era, ecology and biodiversity has attained more importance. So next one. This is also something which was said by a research scientist. He says, I became involved with statistics because mathematics did not provide the avenue to cross into other areas of science and continue to learn about topics that interested me. I have studied statistics because of the diversity that it offers and because of the rational approach it provides to seek solutions. So statistics study is diverse. It is making use of applications in every other field. in all fields. Actually, statisticians are helping others, not for themselves. They are working for others actually. So that is actually, so we are actually doing a service to the humanity. We are doing a service to the scientific society, the scientific community. So we are providing diverse number of methodologies, diverse number of techniques. All our applications are for helping others, helping the advancement of science, helping to make decisions, etc. Next one. Now I am coming to the employment opportunities. So some of you, as far as statistics students are concerned, many of you are having good opportunities even abroad. So you can go to US or Australia or even in Gulf countries. So this UAE, then in England, then in New Zealand and other areas everywhere. You can go as biostatisticians. You can work in pharma industries. You can be good clinical researchers, clinical trials. Accurate science is more concerned with banking and insurance, finance, financial modeling. You can become a government statistician, research and teaching, project management, now cancer research, AIDS modeling, COVID research, public health, epidemiology, genomics, statistical computing, consultancy, market research, business analytics, official statistics, agricultural statistics. All these are actually some or more. There are more opportunities for statisticians. Now come to the next one, opportunities for statisticians in India. So the most important office in government for a statistician is the Indian Statistical Service. You can be like an IAS officer if you join Indian Statistical Service. Then the Central Statistical Organization, National Sample Survey Organization, NSSO. So teaching and research, you can go to Indian Statistical Institute or Indian Agricultural Statistics Research Institute. Then some of the IITs, IIT Mumbai, Kanpur, University of Pune, etc. are good places for doing research in statistics. Then biostatistics, clinical research, clinical trials, finance. You can become an actuary. You can do with insurance. You can be in banking, stock markets, industry. So you can be a good quality statistician, Six Sigma, reliability, then manufacturing. That is, it could help mechanical engineering, process control, capability indices, then signal processing, electrical and communications, then economics. So you can be, and you can help in developing index numbers, wholesale price index, national income, then biology, bioinformatics, gene sequencing, microarrays, the Department of Economics and Statistics. All state governments have Department of Economics and Statistics. You can be appointed as an investigator, then planning board, rubber board, spices board, fisheries, medical colleges, coconut development board, then all universities and colleges, and in even higher secondary schools, you can become teachers. Then, next one. Statistics is used in a wide array range of areas: biostatistics and epidemiology, market research and business analytics, actuarial science and insurance and stock markets, commerce and industry, medicine and health diagnostics, data science and data analytics, space research, remote sensing, journalism, advertising, sports, forensic science and criminology. That is actually concerned with the post-mortem and other things, communications and public relations, government and public policy, weather forecasting, space sciences, social media, and public opinion polls. Everywhere, statisticians are widely employed. That is how this data science and data analytics was developed much. So now, I have specifically considered Indian Statistical Service examination. Statistics or applied statistics, and from last year onwards, even BSc Mathematics or Statistics students can apply. But there is little chance for passing the examination. But even a good student with the BSc Mathematics or Statistics, provided he has studied statistics as a subject, they can apply. Then there are 5 papers. One is actually general studies paper, something general knowledge, and other 4 papers are there. All are descriptive type. No, 2 are objective type, 3 are descriptive type. Then plus an interview is there. Every year, at least 50 vacancies are there all over India. Remember, all over India, less than 500 students are studying for MSc Statistics. less than 500 students are studying for MSc Statistics. 10 into 50. So all over India, less than 500 students are studying for MSc Statistics. So there is sample chance, but out of these 500 students, maximum 200 or 250 will apply for ISS examination. And those who are seriously writing the examination will come to 100 or 150. So if 100 students write the examination seriously, chance is actually 1:2. So similar, so you can write IAS examination, IFS examination, IPS examination. Many of our past students are there in the Indian administrative service. So even now, the present Additional Chief Secretary T.K. Joshi is an IAS officer who had studied MSc, past MSc Statistics from Palay. Then another is actually one Girija, IAS. So who was your collector? Some years back, one Girija, Madam was your collector in Pathanamthitta. So she was actually an MSc Statistics from Pada, St. Thomas College. So only statistics. So that means some of you can become IAS, IPS, IFS, etc. if you want to enter that service. That is actually giving good opportunities actually. Then only statistics related works like surveys, budget, world sale price index, census and planning, data analysis, reports, etc. So if you join Indian Surgical Service, you are actually appointed as an assistant director actually in the first level. So at the age of 23 or 24, you can become an assistant director. At the age of 30, you can become a deputy director. At the age of 35 or 40, you can become director. Then you can go on and you can become the chief statistician of India if you are fortunate. So that is actually equivalent to Union Cabinet Minister's rank. So that is actually the opportunity for statisticians in the official statistics in India. So if you become ISS, it is very easy to pass, not very difficult. It is something. So many students are passing from Kerala. Many students are passing. So try to become an ISS officer. That will be giving you more opportunities. Another is actually teaching and research. So if you want to do research, if you want to become a good teacher, certainly if you want to become a college lecturer, if you want to become a university teacher, there is opportunity. You have to become, you have to pass the UGC CSER test. Now it is conducted by the National Testing Agency, ICMR, ICIR, etc. All these national level tests are to be passed. Then you will be getting scholarships also, fellowships also, GATE examination for IITs. There also, if you pass GATE examination, you can go for research in Indian Institute of Technologies. So there is KSCST, Kerala government is providing support. Department of Science and Technology is giving support. CSIR is giving support. NBHM, National Board for Higher Mathematics. In the Atomic Energy Commission, you can become, you can get employment also. You will be getting good fellowship for research. So fellowship of rupees 32,000 per month for 2 years, plus contingency of 25,000. Then, if you are showing somewhat good progress, then rupees 38,000 per month, plus contingency for 3 years. That is actually, so up to 5 years, you will be getting all these fellowships, even after 5 years. So actually, 3 or 4 years are sufficient for completing your PhD. So even after that, if you want to continue your research, 50,000 plus, etc. That is for postdoctoral research. Postdoctoral research is fellowships are given by Department of Science and Technology, CSER, UGC, IITs, IIIT, Indian Institute of Information Technology, Indian Institute of Science, EIFR. Even during the recent budget, the government of Kerala has offered postdoctoral research fellowships of ₹1 lakh for selected areas in data science, data analytics, and so on. So there also statisticians will be getting opportunities certainly. So remember that. Education and research in statistics. So for education, so what is actually needed? So you have to get a degree in statistics or applied mathematics or data science or data analytics. Then you have to go for postgraduate studies. Now you are all in postgraduate department. So many career fields, gets a master's degree or PhD in statistics or applied statistics or biostatistics, etc. Then you will be getting research funds from UGC, CSIR, NBHM, PhD, CSIR, ICIR, Reserve Bank of India, KLCST, etc. Then certainly apart from this, these are actually for statisticians. Other scholarships are there, minority scholarships, women scientist scholarships, student projects, etc. are also available. Then comes skills needed. So what are the important skills you want to develop? Quantitative skills. So there is actually statistics, mathematics, scientific temper. You should be a good statistician. You should be good in mathematics also. You should be good in computer programming also. You should have an analytical mind. You should be able to work as a team. So statisticians should be able to work with others, with the doctors, with the nurses, with the chemists, with the physicists, so with the engineers and so on. So you should be able to work as a team. Then definitely you should have good communication skills, verbal as well as written skills. So you should be able to write reports. You should be able to explain this to managers, explain this to ministers, computer programming skills, foundations in the fields of application. Suppose you are working in health, certainly you should be thorough with health also. If you are working in the economics department, or if you are working with the finance minister, certainly you should be having some good knowledge about finance also, economics also. So that way you should be thorough with the field of application also. Next one. Now I am concluding. So now National Statistics Day is celebrated in India on 29th of June by the Ministry of Statistics and Program Implementation, Government of India. Only in India, the subject statistics has a ministry, and that is the Ministry of Statistics. There is no Ministry of Chemistry or Ministry of Physics or Ministry of Mathematics. Remember, there is only one Ministry of Statistics, and that is for statistics, for the development of statistics. That is the importance of statistics. So CSO, NSSO, NASA. NASA means National Academy for Statistics Administration, ISI, Indian Statistical Institute, Indian Agricultural Statistics Research Institute. CSO means Central Statistical Organization. NSSO means National Statistical Organization. Then there is Statistical Commission in the national level as well as in the state. National Statistical Commission of India, Statistical Commission of Kerala. Then every 20th of October, World Statistics Day is celebrated by United Nations Organization. Remember that. So that is actually the importance of statistics. So international organizations, next one. So you can become members of this international organization. You faculty members first become some members. The subscription rate is just $30. $30 means some 2,000 rupees, less than that. So annual membership is less than 2,000. So ISI, International Statistical Institute for Mathematical Statistics, that is known as IMS, then American Statistical Association, ASA, students have free registration for free membership for India International Institute for Mathematical, IMS, as well as ASA. You may just go through this. Then RSS, Royal Statistical Society. So in many of these, students have free membership, and faculty members have reduced membership. Reduced membership is even though people from developed countries have to give some $200, $300. You need only to give less than $30 or $40 as membership fee. Then students have Jan Tinbergen Award for Young Statisticians by the Indian Statistical Institute. So one of my research students who got Jan Tinbergen Award at the age of 23, immediately after completing her MSc, she joined for research, and in the second year she got this award. So it is actually around 10 lakh rupees. And she was invited for presenting her research paper in the meeting of the International Statistical Institute. And there she presented the paper along with me, and she was given that award and the expenses towards travel, towards residence and all those things. So that is actually the opportunity for statisticians. So conclusion. Next one. So what I advise you, all of you, is start studying statistics today. All of you have joined MSc Statistics. Now, for others, or who are aspiring for doing MSc Statistics, they have to study BSc in Mathematics or Statistics. Then, along with this, you should study some data science, some data analytics, some Python, so that you can do as part of MOOC courses. So you can join some MOOC courses in Swayam portal, or you can, these are offered by IIT Kanpur and other IITs, Indian Institute of Sciences, are offering this type of massive open courses, online courses. So you just register for that. So if you want a certificate, you need only to give you 1,000 rupees. Otherwise, you can attend these courses freely. And better is to get a certificate. It is very easy, not very simple. In St. Thomas College, some of our students, many of our students are getting these certificates. They have attended these MOOC courses and they have received the certificates, they have scored more than 80% marks. So it is not a difficult thing. So based upon these MOOC courses, if you like everything, you consider pursuing a degree in statistics along with data science, data analytics, etc. That is also important. Just a diploma program is sufficient. So biostatistics, epidemiology, machine learning, etc. These are also developed. So in MOOC courses, you can attend every semester at least 1 or 2. So these are actually very simple, but it is actually helping you to study your statistics courses very well. The possibilities are endless. So next one, conclusion. Data is powerful, better data, better lives. Now I conclude with the definition, next one. So what is statistics? We are just modifying. So statistics is the science of learning from data. It helps to make wise decisions in the face of uncertainty using data and calculated risk. So it need not be systematically collected data. It should be any type of data. And that is actually the advantage of data science or data analytics, etc. Statistical wisdom and deep learning are essential to deal with big data. Next one. Next, I show some slides. Statisticians reduce disease and improve medicines. So how this gene sequencing, etc. is done. So that is actually how statisticians are doing. Next one. This is actually statisticians are consciously making industry more efficient and financial institutions stronger. That is actually industry and finance. Next one. Artificial intelligence, that is speech recognition, machine learning, etc. Next is actually statisticians can even influence votes. So nowadays, governments or politicians are using this word. That is how Trump has won the election. Narendra Modi has won the election. They have influenced the people using social media. So they are conducting every day. They are conducting opinion polls. They are conducting surveys, and they are calculating. They are influencing. They are developing new techniques to attract people. So targeting and assessing the success of government policies and programs. Next one. So even in sports, you are making use of statistics. You study about the strategies used by the players. Next one. It can help in finding Earth's natural resources. So remote sensing mechanisms, etc. This classification techniques, etc. can be used. Even in Mars, even in Moon, we can find whether there is water, whether there is gold, whether there is some mineral resources, etc. in seas, etc. Or for that, statistical machine learning techniques, statistical remote sensing techniques, or those clustering techniques, etc. are widely used. Multivariate analysis techniques, etc. are widely used. Next one. This is actually statistics. This was actually a paper which was presented by the president of the Royal Statistical Society in 2015. At that time, he predicted statistics as the data science for the 21st century. So nowadays, data science has come. So in 2015, the Royal Statistical Society identified statistics as the beginning of data science. So now data science has come out. So that is how statistics has emerged. Next slide. Next, these are actually some websites you students can follow. So you may just write down these websites. AMSTAT, American Statistical Association, www.AMSTAT. Next is IMSTAT, Institute for Mathematical Statistics, IMS. Then ISI, International Statistical Institute's website. You can just go through this. That is very interesting. That will give you a lot of ideas. Then ISI KARL, that is Indian Statistical Institute, Calcutta. MOSPI, Ministry of Statistics and Program Implementation. So all of you just write down these 5, 6. And last one is this is statistics.org. That is also giving a lot of information. You teachers may show our students once again these things, and you can also explain this. It's not my own job. The people can explain these things. We can go to the next slide. So, concluding, that is actually the present era is an era of statistics. Data is powerful. People have identified, people have realized that data is powerful. It is a data-driven era. This is better data, better lives. That has been the slogan for World Statistical Day. Better data, better lives. Ensure quality of data. That was actually the slogan this year. Ensure quality data or connect data through quality. Connect through quality. So that means good quality data is very essential. Otherwise, our planning will fail. So better data will ensure better life for people, better life for humanity, better life for the whole universe. So it is an era of statistics. So remember, data is powerful. It is the data-driven era. Thank you. Next. Okay, thank you. Hello. Kevin. Then other participants. So I have gone a little beyond our allotted time. Anyway, I think it was useful. So any student, if you want to ask some questions, Vinita, you can start with asking some questions. Some of you can ask questions.
Good evening, sir. Sir, എൻ്റെ സംശയം നമുക്ക് സ്റ്റാറ്റിസ്റ്റീഷ്യനായിട്ട് ഇപ്പം എനിക്ക് യുണൈറ്റഡ് നേഷൻസ് ഐ മീൻ WHO സ്പെസിഫിക്കലി ഒരു താല്പര്യമുണ്ട്. അപ്പൊ അതിലേക്ക് ഒരു എങ്ങനെയാണ് അതിൻ്റെ ഒരു പാത്ത്?
അതിൽ ചെയ്യേണ്ടത് വെച്ചാൽ WHO ഇങ്ങനെയുള്ള പ്രോഗ്രാംസ് കൊടുക്കുന്നുണ്ട്. കുറച്ച് ഡാറ്റ അനാലിസിസ് കൂടി പഠിക്കണം എന്നേ ഉള്ളൂ. നമ്മുടെ കോഴ്സിന്റെ ഭാഗമായിട്ട് തന്നെ ഉണ്ട്. ഇപ്പോൾ ഇതിനോട് ചേർന്ന് along with the statistics. So if an elective in biostatistics is there, that will be very good for WHO work. Then you have to study this Python software is also needed. Biostatistics and epidemiology is also needed actually. So that you can do as a MOOC program, MOOC course. So in the SWAYAM website. So many universities, this IIT Kanpur is offering them. So during this season or during usually June, July, August, they are giving registration. Nowadays, I think registration is online. Nowadays, you can just go through this SWAYAM portal or IIT Kanpur, Indian Institute of Science, etc. So you just click on MOOC courses in India or MOOC courses offered by WHO. WHO is also offering. All these courses are free of cost.
Sir, one more. Hello, sir. ചോദിച്ചോട്ടെ സാർ? ഒരു ഫീൽഡിനോട് എനിക്ക് താല്പര്യമുണ്ട്, ഡിസാസ്റ്റർ മാനേജ്മെന്റ്.
ഡിസാസ്റ്റർ മാനേജ്മെന്റ് കുറച്ചുകൂടി നമ്മുടെ ഈ സ്റ്റാറ്റിസ്റ്റിക്സ് ഫീൽഡിൽ നിന്നും വ്യത്യസ്തമാണ്. പക്ഷേ ഈവൻ ദെൻ ദാറ്റ് ഇസ് ഓൾസോ മേക്കിംഗ് യൂസ് ഓഫ് സ്റ്റാറ്റിസ്റ്റിക്സ്. സർട്ടൻലി ഡിസാസ്റ്റർ മാനേജ്മെന്റിലും കൂടുതലും സ്റ്റാറ്റിസ്റ്റിക്സ് ആണ്. എങ്കിലും അത് എഞ്ചിനീയേഴ്സിന്റെ ഒരു ഫീൽഡായിട്ടാണ് കൂടുതൽ വെപ്പ്. ഈവൻ ദെൻ ദർ ഓൾസോ യു ക്യാൻ ഹെൽപ്പ് എഞ്ചിനീയേഴ്സ്. ഡിസാസ്റ്റർ മാനേജ്മെന്റില് നമുക്ക് ഈ ഡാറ്റ അനാലിസിസ് മാത്രം പോരല്ലോ, അതിനെ കറസ്പോണ്ടിങ് ആയിട്ട് നമ്മൾ കെട്ടിടങ്ങളൊക്കെ പണിയുമ്പോൾ വേണ്ടതായ എഞ്ചിനീയറിംഗ്, സിവിൽ എഞ്ചിനീയറിംഗിന്റെ ഒരു സ്പെഷ്യലൈസേഷൻ ആണ് ശരിക്കും ഡിസാസ്റ്റർ മാനേജ്മെന്റ്. ഈവൻ ദെൻ ദർ ഇസ് ഓൾസോ പോസിബിലിറ്റി. അവിടെയും സ്റ്റാറ്റിസ്റ്റിക്സ് നല്ല റോളുള്ള ഒരു സ്ഥലമാണ്. ഈ ഡാറ്റകളെല്ലാം അനലൈസ് ചെയ്ത് അതിന്റെയൊക്കെ ഈവൻ ദെൻ സിവിൽ എഞ്ചിനീയറിംഗിന്റെ ഒരു സ്പെഷ്യലൈസ്ഡ് ആയിട്ടാണ് അതിനെ കണക്കാക്കുന്നത്.
താങ്ക് യു സർ.
ഈ WHO എല്ലാ പ്രോഗ്രാമുകളിലും നമുക്ക് വളരെ വലിയ റോളുണ്ട്. Any other?
Students, you can use this opportunity to ask questions.
ചോദിച്ചോളൂ. ഓക്കെ, you can ask. സമയത്തിന്റെ പ്രശ്നം ഉണ്ടെങ്കിൽ നിർത്താം, എനിക്ക് കുഴപ്പമില്ല.
Thank you, sir, for such an informative session. I'm sure the students have got an overall view of the subject and its opportunities.
With equal pleasure, I request Professor Ebin John program to propose the vote of thanks.
Respected Principal Matthew P. John, sir, respected Joe sir, DGBs, Biju sir, Benno sir, and all other faculty members and students. കഴിഞ്ഞ 1.5 മണിക്കൂറായിട്ട് നമ്മുടെ സ്റ്റാറ്റിസ്റ്റിക്കൽ സബ്ജക്റ്റിന്റെ ബേസ് തൊട്ട് സ്റ്റാറ്റിസ്റ്റിക്സ് ആസ് എ ഡേറ്റാ സയൻസ് എന്നുള്ള രീതിയിൽ വളരെ ഇലോബറേറ്റ് ആയിട്ട് ജോസ് സാറ് നമുക്ക് സെഷൻസ് ഹാൻഡിൽ ചെയ്തു. വളരെ തിരക്കുകളുള്ള ഒരാളായിട്ടും നമ്മൾ ഇങ്ങനെ ഒരു സജഷൻ പറഞ്ഞപ്പോൾ തന്നെ സാറ് വളരെ പോസിറ്റീവായിട്ട് റെസ്പോണ്ട് ചെയ്യുകയും ഈ ഒരു ഇവന്റിനെ ഇത്രയും മനോഹരമാക്കി തീർക്കുകയും ചെയ്തു. സ്റ്റുഡൻസിന് ഈ ഒരു ക്ലാസ് കൊണ്ട് ബെനിഫിറ്റ് ഉണ്ടായി എന്ന് ഞാൻ വിശ്വസിക്കുന്നു. സാറിന്റെ അടുത്ത ഈ റിപ്പോർട്ടിന് ഈ സ്റ്റാറ്റിസ്റ്റിക്സ് ഡിപ്പാർട്ട്മെന്റിന്റെ പേരിലും ഞങ്ങൾ ഓരോരുത്തരുടെയും പേരിലുള്ള നന്ദി അറിയിച്ചു തന്നു. ഈ ഒരു പ്രോഗ്രാം നമുക്ക് കണ്ടക്ട് ചെയ്യാനായിട്ട് എല്ലാവിധ സപ്പോർട്ടുകളും തന്ന സെന്റ് തോമസ് കോളേജ് പ്രിൻസിപ്പൽ മാത്യു പി ജോൺ സർ, HOD ലിജി മിസ്, കാലടി കോളേജിലെ HOD ബിജു സർ, BCM കോളേജിലെ HOD സ്റ്റെഫി സർ, ബെന്നോ സർ, മിനി മിസ്, മറ്റ് ഫാക്കൽറ്റി മെമ്പേഴ്സ് എല്ലാവരോടുള്ള നന്ദി അറിയിച്ചു കൊള്ളുന്നു. ഈ ഒരു പ്രോഗ്രാമിൽ ആദ്യം അവസാനം പാർട്ടിസിപ്പേറ്റ് ചെയ്ത എല്ലാ കുട്ടികളോടും നന്ദി അറിയിച്ചു കൊള്ളുന്നു. ഈ ഒരു പ്രോഗ്രാമിൽ വിജയകരമായി നടത്താൻ സഹായിച്ച എല്ലാവർക്കും ഒരിക്കൽ കൂടി നന്ദി അറിയിച്ചുകൊണ്ട് നിർത്തുന്നു.
താങ്ക് യു ആയിക്കോട്ടെ, നിർത്തിയേക്കാം.
ഓക്കെ സർ, താങ്ക് യു.
Thank you one and all for your cooperation.
Thank you all.
For all the participants for being a part of this event.